lost. What would be the future? Could you pay the cost? You wonder, will there ever be a second time around?
Oh, hi there. Welcome to CE 291 Lab. This is the first introductory video to the DAQ portion of the class. So why don't we start by looking at what's at our lab stations. So as you can see, I'm typing here at our super fast computers. And each lab station has its own wooden shelf that has all the materials you'll need to be a successful student in this lab. Up on the top shelf here, we have our multimeter, which will let us measure voltage, amps, and resistance. We have our resistance substitution box, which will let you make any resistor you want. We have in here our little box of goodies that has all the cables and cords to connect to the multimeter, to connect to some of the other things. In here we have a microphone, which we'll use later in the class. We have our power supply, which will let us set voltages and currents. Right here we have our data acquisition device, which will let us record data. And then finally over here we have what we're calling our central signal ports that will allow us, the TAs, to send out some voltages to you. You can plug your cords right in here and record what we're sending out. Alright, so the first instrument we're going to look at today is the digital multimeter. And as I said previously, the multimeter can measure voltage, resistance, and current, and that depends on where you plug in your inputs to. And so if we look here, we see voltage, resistance over here, and these ports over here are for amps. So what we have to do is plug in our test leads, which are these two probes here. And so the black probe always gets put into this port labeled COM, which means common. Okay? So if we want to measure voltage, we look at to see which port we have to plug into, and we see that the V right here stands for voltage. So then we can plug in our red lead into voltage. Okay? So one thing to remember is that black is always negative, red's always positive. So we turn the multimeter on with this orange button here, and it reads out something very small, 10 millivolts. And if we want to measure the voltage of this battery here, we need to take the black test lead, touch it to the black probe of the battery, and the red test lead, and touch it to the red probe of the battery. And we see that the battery measures 6 volts, which is what we expect because it is in fact a 6-volt battery. Now, if we want to look at resistance, we have a resistor right here, and we have to rethink at how to set the multimeter up. So we look at what port we're plugged into, and we see here that we're in the resistance port, but we also have to check this dial. Before we are plugged into the voltage, we have to switch the dial to this ohm signal, which means resistance. And to measure the resistance, we simply put the test leads at both ends of the resistor, and we see that it is a 10 kilo ohm resistor. Finally, if we want to measure current, we look down at the ports again, we see 10 amps. Amps is a unit of current, so we have to switch our red test probe into this port. And then if we look on our dial, we see amps over here, so we have to switch our pointer all the way down to here. Alright, here we have our DC regulated power supply, which will let us output a current and a voltage that we specify. Over here we have the power switch, so let's turn it on. And you can see on this display we read out the voltage, and this display we read out the amperage that's coming out of the power supply. And those are set by these knobs right here. If I turn this, I can turn the voltage down or up. And the current similarly. Since we don't have anything drawing current right now, it's not changing. But if we did, we would plug it in right here, our negative port and our positive port, black and red. Our power supply also has the option of outputting a constant voltage if we plug in Right here, we get 12 volts at a half an amp, and if we plug in over here, we always get 5 volts at a half an amp.
The DAQ devices have been upgraded to the LabJack T7 Pro. These DAQ devices allow us to sample voltage at a much higher frequency than can be accomplished with the multimeter. You can see many different screw terminals available on the LabJack T7 Pro. In this class, we will only be using the analog in 0 and the ground ports to measure our signals. To do this, you must just simply connect the bare wire into the terminal and screw it down securely. In this lab, it's beneficial to use the banana plugs because we'll be measuring signals from the central signal port. So the banana plugs plug in quite nicely to the central signal port. And then later in the lab, we'll also be measuring from the power supply, so you can remove the banana plugs from the central signal port and simply plug them into the power supply. The DAQ device is driven with a GUI in MATLAB. GUI stands for Graphical User Interface. To run the GUI, you must download 2 files from the course website, a .fig, which is the layout for the GUI, and a .m file, which contains the MATLAB code that drives the GUI. Open the M file and click Run. The GUI window will pop up. The user may enter the duration or how long they wish to sample the signal, 5 seconds, the sampling frequency, or how fast we're going to sample the signal. In this case, we will sample 100 times per second. And the last field is voltage range. The LabJack T7 Pro allows 4 different voltage ranges, 10, 1, 0.1, or 0.01. If the user enters an incorrect voltage range, the GUI will pop up with an error message. In this example, we will use 10 volts for our voltage range. Click Start to begin sampling, and notice a real-time plot of the data being collected. Once the duration has been achieved, a new figure window will pop up showing the data sampled. The user may zoom in on specific points of interest and use the data cursor to view voltage levels. Also notice in the workspace, 2 vectors will be created. Data, which contains the voltage, sampled, and time, which contains the times. The user may save these vectors by clicking the Save button and choosing an appropriate MAT file name. The user may also reset all the fields and start fresh.
Alright, so as a general overview of the first lab, what we're going to be doing is going to use the multimeter and the data acquisition device and look at a couple signals, record them, and use that data to analyze the sampling frequency, the resolution, as well as the accuracy. And then at the end, you'll have some time to play around with circuits and look at Ohm's law. And if you follow the directions step by step, you should be just fine.